All right. Good afternoon, students. My apologies. Today I could not meet you because of a meeting that I was attending. However, that does not mean uh, uh, we should stop learning. So, last time we were looking at Java methods. Last time we were looking at Java methods, where I was teaching you how to implement methods, how to declare methods and everything. And from what I taught you last time, I had explained to you guys to say, when we're talking about a method is just what a group of what of codes, right? That are to execute something. This is a group of code to execute something. I also told you that there are many different kinds of methods. We've got the methods that are predefined, the method which we are predefined. They come with the compiler or they come with Java, as well as we've got methods that you can create for yourself. And I showed you last time when we were working with the method to add. I believe you still remember we're working with the method to add two numbers. So we learned how to use the static keyword, and then how when not to use the static keyword, how to access methods, how to create objects in order to access methods. I have explained that to you. So after explaining all those things, now this pushes us to learn something new today. And the particular thing that I want us to learn today, it is called recursive or recursion methods, or recursive method. So what is a recursive method? A recursive method is it's a method that calls itself. It is a method that calls itself. That's a simple definition, and I hope you do get it. So it is very, very important to start understanding the concept from the definition, because if you miss understanding it at the point of a definition, it will be hard for you to understand it when it comes to implementation, because every implementation is hidden somewhere on what on the definition. So in Java, a method that calls itself, so the key word here is what calls it what itself, it is known as a what as a recursive what method. So but the process of the method what calling itself, it's now called what a recursion. The process of what of the method what calling itself, it's called recursion. Don't misquote the two. A method that calls itself, it's known as a recursive method, and this the process of calling itself, it's called what recursion. So we let's try to look for physical examples. Let's try to look for examples that are already there in the world, or our everyday example where we apply these this concept. So a physical world example will be to place two parallel mirrors facing each other. Any object between them will be what will be reflected recursively. So in other words, you're saying you're putting the first mirror here, you put the second mirror. So any object that will come in between will be what will be reflected that side, will also be reflected that other side. That's what recursion is all about. That is what recursion is all about. So let us try to look at how recursion works, right? How recursion works. So there's a diagram that I'm just going to try and find ways so that I can explain. I hope you will understand. Uh, you will understand that. So as you can see right here on the code given on the screen, or the code that you're seeing, as you can see, we've got public static void, main string, and recurse everything. This is just an example of our main method. You know what our main method is all about. So after that, as you can see, static void, I want to explain what static is all about. I want to explain what void is all about. All you need to know is this is the method. You see, this is the method. This is the method that we're creating. So this is how one can what can access the method. Remember, the reason why we are accessing it like this is because we have used the keyword static. Never forget that. Never forget that. So this is the method what? The method call. As you can see, this is the recursive call, and yes, that's the recursive call. However, let's try to explain to get into the explanation of the code. So in the above, let me put it like this so that you can clearly see it when I'm busy, explaining it. So in the above method, we have called recurse. We have called what? Recurse. We have called recurse method inside the main method. Inside, we have called this one, right? We have called this recurse inside the main method, a normal method call. And inside the recurse method, we again calling the same recurse method. So as you can see, here we are calling what? We are calling which method? This one. This one. But inside again, we are calling what? The same. So that is the idea of what? Of recursion. So look at this. We are calling the recurse method what? On the main method. Again, we are calling the method inside what? The same what? Method. Which means that if a method is calling what? Is calling itself. I believe you will still uh, 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 I believe you still, yeah, you're still with me right now. I believe you're still with me right now. So a method is calling. Remember, a method is calling another method. It's calling itself continuously because already here we've got the recurse method. Then we declared it again inside, and again we are calling it where? On the main method. So we are calling what? The same recurse what method, and then that is what we call a recursive what call. In order to stop the recursive call, we need to provide some conditions inside the what? The method. Otherwise, the method will be called what? Infinitely. Otherwise, the method will be called infinitely. I don't know if I taught you guys about the infinite loop. The infinite loop. I'm not sure about that, but I should have touched on that one when you're dealing with the for loop. I think I had explained that if you don't put certain conditions, the loop will continue to what? To loop, 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 loop. But there must be what? Conditions that you put in place. When you have put those conditions in place, what will happen is that when the method is done, it will what? It will cut. So same here when we are dealing with what? With the recursive functions, we need to take that into consideration. So right now, I want us to I want us to have a little bit of a coding exercise so that we can see how we can how one can be able to code these recursive functions. So I'm just gonna share my screen. As I'm sharing my screen, I will show my notepad plus plus. As I'm showing my notepad plus plus, we'll be coding this thing together so that you see. I want to give you a simple example that you guys must see how where we use these recursive functions. Mainly when we are dealing with a factorial number. I believe you guys know the algorithm behind factorial numbers, right? I believe you guys kind of like understand, have an idea what factorial is all about. So for an example, before I get into the code, let's say we want to find the factorial of 4. 4 for what? 4 factorial like that, right? I believe you've seen this in your calculators and and everything, right? So this is the same thing as 4 multiplied by what? By 3 multiplied by 2 multiplied by 1. Then we'll get what? The answer. Then one can get the answer. So this is the basic what algorithm that runs behind what the issue of factorial. Already you can see and on how these numbers are multiplying each other going down. You can what? You can tell that a method is what? you can use recursion here, because a function can call itself, or a method will be what, calling itself until a certain condition is met. But if that condition is not met, it will what, it will continuously what, it will continuously run. So let's try to implement such this function and see how it works. We try to run it and you see how it works. So let me clear my screen, and I hope you will be following. So the first thing that we can do, you can say public static. Um, let's use, because most numbers that we use are whole numbers. So let's just do it like that. Um, and right there, let's just put one argument, and right, we are creating a method, right? So the method should be if n is not equals to what, to 0. I want you to follow me very closely. I want you to follow me um, very uh, closely on what I'm doing right now. So if n is not close to, I mean, if n is not equals to 0, then let us return what? Let us return n multiplied by factorial n minus 1. I taught you about return, right? I taught you about um, return, statement. So if everywhere where n, if n is not equal to 0, meaning that every n that will not be equal to 0, because we cannot use it must not be equal to 0. So if n is not equal to 0, then what you're supposed to return is n minus what? Minus 1. You will understand this in just a moment. Let me finish the code, then I think I will explain the code after I'm done. Let's just remove, I don't know why I always forget that. I don't know why I always forget that. However, we will see what to do. However, we'll see what to do. So let's have int number, which is assigned to what, to 4, which is assigned, which is assigned to 4. Then let's do dynamic initialization, right? Or for the sake of people who don't understand, we can have result, then we have result factorial number. Okay, then after that we have result we are placing it into what, into our method right there. Oh, making the same mistake. So this will be system.out dot, then we have number plus this result should be small letter. Okay, all right, so there we go. We have our code, and then up there we have got our function. This is our condition. All right, it runs with this condition. It runs with this condition, and I would not like us to take uh, granted of that condition. So, all right, let us try now to run this code and see what will happen before I get into the explanation. I know at this point, maybe most of you you're lost, but you're not really lost. After I explain, you will understand what I'm trying to do. So let me quickly share my screen. Then we have check my class .java. Line number 9, we have got an error. Let's quickly go to line number 9. We have an error somewhere. All right. Clear screen. What? Oh, all right. Let's go back to our code and we try to see what's happening on our code. All right. There we go. We have our code. Let's remove that. Oh, and I'll get where the error is. Let's do it this way, right? If cannot be, let's put it this way. Else return 1. Right. Let's go back to our code. Try to see. Voila, we have managed to solve. The thing is, I had left the else part. So if n is not equals to 0, which means it's 1 above, right? It will go to our, it will return the method that we have placed, the n multiplied by factorial n minus 1, because it's a recursive call. It will be calling out itself over and over. Else, it will just return 1. Okay, the same principle they use, the same algorithm they use when calculating this thing. You see, now the 4 factorial is what is 24. 4 factorial is 24. It keeps on what? Calculating itself. So it will be like 4 multiplied by 3 multiplied by 2 multiplied by 1, and then it ends at what? 0. It will not be what? It will not be counted right there. So, okay, let me try to explain what was happening. Let me try to explain what is happening in this code, because I know most of you are asking yourself that, hey, say we don't understand anything. So in the above example, we have a method of which we named it what? Factorial, right? We have a method of which we named it factorial, and the name, the method that I'm talking about is this one, right? We have named it to be what? To be called factorial. Then factorial is, we are calling it on the what? On the main method. As you can see, we are calling it on what? On our main method, with the number variable passed as an what? As an argument. As you can see, the number variable is passed as what? As an argument, right? Fair enough. I believe all of you understand. But the tricky, I think the tricky part that I have to explain and re-explain and explain, it is this part. It is this part. So the factorial method is calling itself. Initially, the value of n is 4 at the initial point. It's what is 4, right? Inside factorial. So what we're trying to say here, the value will be what? Will be 4, right? Because of here, right? We just put in 4. Then during the next recursive call, it will be what? It will be 3, because remember, these 4 subtract by 1, it will be what? It will be 3. It continues again. Remember, when it continues, okay, or let me put it this way. Let me just clear everything so that you can understand. The initial value of n here, the initial value of n will be what? Will be 4. I hope you guys are understanding where we are getting the 4 here, right? Because we have defined it here, then we have passed it over just like that, right? So that's where we are getting the value of what? Of n. I believe, guys, you are understanding. I believe that you understand this thing. So uh, this number is being, we have passed it as an argument. So whatever number, this 4 here, it's getting inside there. So I hope you do understand that. All right. So the first initial value will be 4, right? So it will be what? It will be 4. Then when it continues again, because of this n minus 1, based on the algorithm of what of what is it called, of factorial, right? It will subtract 1. It continues again, subtracts 1, multiply, subtract, multiply, subtract. So there will be a multiplication and a subtraction, a multiplication and a subtraction, multiplication and subtraction, just like that. So during the next recursive call, 3 is passed to the factorial method. The process will continue until n is what? Is 0. And when n is equal to 0, the if statement returns what? False. Hence, 1 is what is returned. Finally, the accumulated result will be what? Will be passed into what? Into the method. So it only brings what? The final result here. It only brings the final what? Result. So it will move doing the same thing. Move, loop, move until n becomes 0. Until n becomes 0. Immediately when n becomes 0, that's it. It's done. So this is just an example of what? Of a recursive function. I believe I'll have to kind of like repeat this as well on Friday. I will also have to repeat this on Friday. However, I will be continuing. Uh, 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 however, I will be continuing with the factorial lesson. I think by tomorrow you will have another video so that I can explain in depth. I know in this video I just touched there and there and I didn't explain in depth. But in the next video, I will try by all means to explain. I will draw sort of a code, explain bit by bit, line by line, so that you can understand. But this is just to introduce you to what we call recursive functions, because you will have to use them in a lot of areas. All right, guys, thank you very much. I hope you will enjoy this video, and anywhere where you will be meeting troubles, don't hesitate to contact me. I'm always available for you, and thank you.